Hey guys, Mr. Middleton here. Today we're going to talk about the isosceles triangle theorem. At the end of this video, you should be able to use the isosceles triangle theorem and its converse to solve problems and complete proofs. Okay, remember that isosceles triangles have exactly two sides congruent. The isosceles triangle theorem says if two sides of a triangle are congruent, then the angles across from those sides are also congruent. Alright, and so in this diagram we see that ST is congruent to UT. It's an isosceles triangle, and so the angles across from it, and I always just kind of can imagine arrows here. Okay, the angles across from it is pointing to those angles that should be congruent, are also congruent. So angle S is congruent to angle U. Okay, in this particular triangle, angle T is the vertex angle, and the other two angles are called base angles. Okay, notice that the isosceles triangle theorem is a conditional statement. Remember the if-then statements. So let's write the converse of this isosceles triangle theorem. Remember that the converse is flipping the hypothesis and the conclusion. Okay, so the converse of the isosceles triangle theorem would say if, we'll just say the base angles of a triangle are congruent, okay, comma, then the sides across from those angles are congruent. Alright. So this is the converse of the isosceles triangle theorem. If the base angles of a triangle, I'll add that in. If the base angles of a triangle are congruent, then the sides across from those angles are congruent. And so, using the converse, let's make a statement. So we have this triangle where we have base angles. Angle P is congruent to angle Q. We can tell by the markings. And so we can say, well, if we know that, then we know that RP is congruent to RQ. Okay. The conditional statement, we would say if angle P is congruent to angle Q, then RP is congruent to RQ. Okay, so we made that into an if-then statement. Okay, so we can go either way. Knowing the sides, we can figure out the angles. Knowing the angles, we can figure out the sides. Okay. Alright, does it make sense to prove triangles congruent here? Alright, what do I need to show? We're going to go through and we're going to try to see, we're going to try to find or make this proof. So here we go. Question is, does it make sense to try to prove these congruent? What are we trying to prove? We're trying to prove that triangle TRS is an isosceles triangle. So are we trying to prove that two triangles are congruent? No. So does it make sense to prove that two triangles are congruent? No. What do I need to show? I need to show either that two sides are congruent or that two base angles are congruent. Either one of those, I can use the converse of the isosceles triangle theorem or the isosceles triangle theorem. Okay, so let's walk through these proofs. So we have WV is congruent to WS. WV, WS, WV, WS. Okay, that's given. We didn't have to do anything for it. It's marked. Okay. Angle S is congruent to angle WVS. WVS, angle S. Okay. So, important for us to know what they're talking about. So when they say angle S, has to be this one. There's nothing else that it could be talking about. WVS, okay, already marked for us. Okay. All right. Now, the question is, why can we say that angle V and angle S are congruent? Or sorry, angle WVS and angle S are congruent. Well, we see that WV is congruent to WS, and this is in the triangle. So this is the isosceles triangle. So it's the isosceles triangle theorem. Okay. Now the next question says WVS is congruent to angle R. So angle WVS is congruent to angle R. Why do we know that? Well, that's given. It's already marked for us. We don't have to do anything for that. And so now we can say, well, if S is congruent to WVS and WVS is congruent to angle R, then we can say that angle S is congruent to angle R. Remember, that's the transitive property. And so, if we look at this big triangle TRS, and I'm just going to redraw it here just so you can see it a little bit clearly, or more clearly if we didn't. We look at this big triangle, we marked S and R as congruent angles. And so you should notice that, hey, the base angles of this triangle are congruent. So now we can say, well, TR has to be congruent to TS because of the converse of the isosceles triangle theorem. Right? Because the isosceles triangle theorem says, hey, if we know the sides, then we know the base angles are the same. The converse says if we know the base angles, then we know the sides are the same. And so now we can say triangle TRS is an isosceles triangle based off of the definition of an isosceles triangle. Because we know an isosceles triangle has two sides the same. Exactly two sides the same. And so we just proved that that was the case. Alright. Flipping to the back. Find the values of the variable in each diagram. Okay, so here we're given two isosceles triangles. Notice first that this is saying this side is congruent to this side and this side is congruent to this side. It is not saying that those sides are congruent to each other. Okay, so this is an isosceles triangle. These sides are congruent. That means that these angles should be congruent. So if this is 65, this has to be 65. Okay, still see that bow tie type shape. And remember that with those bow tie type shapes, always looking for vertical angles. And so these vertical angles are congruent. Okay, this is an isosceles triangle, right? Pointing to this angle and this angle. So these two angles should be the same. So if this is 65, this is 65. Now neither of those 65s are x. In this triangle we know that all three angles should add up to 180. 65 plus 65 is 130. 180 minus 130. I guess 130 plus x. And so x should be 50 degrees. Okay. Number two, working through the same kind of way. Trying to find x. I see that it's in the isosceles triangle. I need to know what these angles are, though. Okay, so only number I'm given here is 70, so I know that has to be, or probably is going to be important to me. This is 70, and it's an isosceles triangle, right? And so that means the base angles are going to be the same. Even though this whole thing is marked 90, I know that inside here is 70, and that must mean that this is 20. Right? Okay, so if this is 20, then that makes this 20, because they're base angles of an isosceles triangle. 20 plus 20 is 40, plus x is 180. So 40 plus x equals 180. That means x should be 140 degrees. Okay. Next, we're going to find the values of the variables given that the perimeter of triangle PRS is 26. Okay, now let's notice that they tell us something before we start. We see that these two angles are the same. Knowing that these two angles are the same helps us out because that means that we know that these two sides are the same. So starting off this problem, I say, okay, x should be the same as y plus 3. They also told us that the perimeter is 26. So x plus y plus 3 plus 3y equals 26. And now I just need to solve for the variables. Okay, I can't solve any of these equations how they're set up right now because they have two variables. And so what I need to do is find a way to get rid of one. If you look at the first equation we have x equals y plus 3. And so we see that x and y plus 3 are the same thing. So now instead of writing x, I know I can say, hey, x is the same as y plus 3. I can write y plus 3 there and rewrite my equation so that I actually have an equation with one variable that I can solve. And so now I take all my like terms, 5y plus 6 equals 26. 5y will equal 20, and that means y will be 4. And if y is 4, I can plug that in here. That means x has to be 7. X equals 4 plus 3. Okay. And I can make sure that it all works out. Plugging this in, that would make this 12. That would make this 7. That would make this 7. 7 plus 7 is 14, plus 12 is 26. That's what they said at the beginning, so we're good. Alright, so corollary to the isosceles triangle theorem, and it says this. First of all, you need to know what a corollary is. A corollary is an idea that follows directly from a proven theorem or postulate. So it's basically if you know this, then this has to be true. Or if you accept this as fact, then you have to accept this next thing as fact as well. Okay, and so here is our corollary. It says a triangle is equilateral if and only if it is equiangular. Okay, and this is the biconditional, meaning it is true in both directions. The conditional and the converse are both true. Okay, so if we know that a triangle has all the sides the same, then we know that all the angles all the sides congruent, then we know that all the angles are congruent. Okay, and if we know that all the angles are congruent, then we know that all the sides must be congruent as well. Okay, so let's use that information to solve this problem. If you notice here, we have an equilateral triangle. It told us that all the sides are the same, right? And we're going to use that information to say, hey, if it's equilateral, we know it has to be equiangular. So that means they have to be the same. And this helps us to find m and n pretty easily because they told us that this was 90, and so that means this must be 30. 30 plus 90 is 120. What's left? 60. Okay. All right. So there's the isosceles triangle theorem. Using that in proofs, being able to solve problems algebraically using that information as well. All right. See ya.